In this example video, we need to write an equation for this sine graph. When we're writing equations for graphs where the period might be different, or the phase shift might be different, or the vertical shift might be different, we really need to take a look, and this is especially important for phase shifts. Because after all, sine and cosine curves they look almost identical, they're just shifted over a little bit from each other. So we need to write a sine curve. Now you might be looking at this and saying, Mr. Valsa, wait a minute. It starts up first. I'm writing a cosine an equation. You could. There's really an infinite number of equations you could write for this, but we are specifically asked to write a sine, that this is a sine curve, so we need to write a sine equation. So let me move this up just a touch, and so I think you can see the bottom here, which gives us a little bit of a scale. What I like to do with these problems is I first like to figure out where my midline is. So for this problem, kind of an easy thing to do is to draw your top line and then draw your bottom line. Oops, that's going to be a little bumpy. I hit my fingers there. And then we're going to figure out what is halfway in between, and that's going to be the midline. So it looks like we have 4 and 2. Halfway in between would be right here at 3. So we know that the vertical shift for this one is going to be up 3. You can draw this here if you'd like. It's not totally necessary at this point, but it can help a little bit. So we know that we'll write that over here on the side, that the vert shift is plus 3 or up 3. The next thing we need to do is we need to draw ourselves a regular old sine curve that has this vertical shift as well. So a regular sine curve would start here at the midline. At pi over 2 it's going to reach its height, and then at pi it's going to come back to 0, and the sine of pi is 0, but we're always adding 3, and that's why all the y values are up 3. And then here we're going to come back, come down to -1, or at least down 1 from the midline. And then for this one we're going to come back up to 0. So if we were to draw this curve would look something like this. We're just using this curve to help us to see where the phase shift is. Okay, so now that we have that, we can tell that from a normal, regular old sine curve, that every single point needs to be moved left by this distance, pi over 2. So the phase shift is left pi over 2. That will move every one of these points onto the one that we want. Let's try to write this equation now, and I'm going to move this back down a little bit because we now have the information that we need. So stick with me here as I try to get this a little bit more visible for you. Okay, so we're going to try to write this equation actually right here in the top of this thing. And what we'll do then is we'll try to find C and K. Now C, it looks like the K, it looks like the period here is going to be 2 pi. So when the period is 2 pi, that's equal to 2 pi over K. So we know the only value that we need for K here, the only one that would work would be 1. So K is 1. We also need to know what C is. We know the phase shift is pi over 2, and that's equal to C over K. So we also know that C is pi over 2. What this is allowing us to do is it's allowing us to write our actual equation. Notice that this graph here is not reflected, so we don't have to worry about that. So we'll write y is equal to, the amplitude is 1, so we don't have to worry about that. The cosine of just theta, because k is 1, coefficient is 1 here. And then remember that we need to go left by pi over 2, so just write the opposite sign here, and then c is pi over 2. we just need to finish this one out. I'll try to move that down a little bit so you can see it a little better, I think. So we just need to then take into account the vertical shift, which is up 3, and put +3 here. And I totally screwed this up. This should be a sine curve. I kept saying it. And now we're looking a little bit better. So if you graphed y is equal to the sine of theta plus pi over 2 plus 3 in a graphing calculator or in Desmos, an online version or something of that sort, you will find that you'll wind up with the graph here in black.